Okay, so this is part 2 of the video. I'm going to do a couple more questions here to finish off. Right, so this is the higher paper, paper 1 non-calculator from 2020. Right, so question 9, what we need to do now is we need to order these numbers from smallest to biggest, but they are not all in standard form. Some of them are, some of them not. So there's 2 ways to do the question. You could write each number in their original form, or write them all in standard form correctly and then compare them. So what I'm going to do is the first one is already done. That is standard form. The first number is in between 1 and 10. The second one is not. Okay, the decimal needs to be going here. So it's 6.72 times by, and then if you look at that power, because it's actually moved 1 unit to the left, that means that this is going to change to a -3 because it's moved 1 in the correct direction. Right, the next one again, this time it's going to be moving 2 place values. So this 10 to the power, because it's moving 2 place values actually away from the number, that is going to change to a 6. And then the last one, we have to actually write it in standard form. So there's the decimal, and the decimal has to be here. So you can see that the number has to move 1, 2, 3, 4 places. So that's going to be 10, and it's going to be -4 because the decimal has to move eventually to the left. Right, so now that I have it, all my numbers are the same, but it's the powers that are not the same. So that is what I'm going to compare. So start off with the smallest one. So if I look at each one, you can see, looking at the powers, -4 is the smallest. Then if I look at the rest, the next smallest is -3. So that's going to be 2. Then the next smallest is 5, so that's 3. And then the last one, this is the biggest number, which is going to be the last one. So when you write it in, I always write them back as they were. So number 1, I can write as 0.000672. Oh, I went over the line a little bit. Right, the next one is going to be, so 67.2 times 10 to the -4. The next one is 6.72 times 10 to the 5, and then that last one is 672 times 10 to the 4. Right, next question, we have a ratio question, and it says, given that A over B equals 5 over 2, and B over C equals 3 over 4, can we write the ratio A to B to C? So what I'm going to do first is I'm going to change the fractions to ratios. So I'm going to write A to B in the ratio of 2 to 5. And then B to C is 3 to 4. So now we've actually started to write it in this ratio form. Right, the next thing we're going to have a little look at is have a look at how B is the common factor of both of these. This is the common thing that is in both ratios, but if we look, B is 5 in one of them and it's 3 in the other. So what we need to do is we need to make that number common, so a common factor of this. So what I'm going to do is, like you would do it if you were making fractions equivalent, I'm going to make the ratio basically equivalent. So I'm going to multiply this fraction, ratio by 5, and I'm going to multiply this ratio by 3. And then that way we're going to have the same number. So A is going to become 6, B is going to become 15. In the second ratio, B is going to become 15 and C is going to become 20. Now you'll notice that B is exactly the same, so I can now write the ratio A to B to C because I can link these two things together. So it's 6 to 15 to 20. Right, okay then, so the next question we're going to have a look at is some indice rules. So the first one, it's saying the 4th root of 81 times by 10 to the 8. So what the best thing to probably do here is split it up. So say, okay, I'm going to do the cube root, not the cube root, the 4th root of 81, and I'm going to times that by the 4th root of 10 to the 8. So 4th root means a number that's been times by itself 4 times to get 81. So it's going to be quite small. So the answer here is 3. 3 times 3 times 3 times 3 is 81. And then here, the cube root of 10 to the 8th. So what you could do here is look at the laws of indices. So I know that a root is actually referring to a fraction. So I could write this as 10 to the 8th. And instead of the 4th root, I can write that to a quarter, because that's what that means. And then I can use my laws of indices. So 8 times by a quarter is going to give me 8 over 4, which is just 2. So this can change to 10 squared. So 3 times 10 squared, well, 10 squared is 100. So the answer is 300 for that one. So 2 marks. Right, the next one, we're going to have a little look at the law of indices. So we have a negative and we have a fraction. So we've already just spoken about the square, well, it was the 4th root. That root is what we expected a fraction to be. So here, I'm going to deal with the negative first. So when you have a negative, it's referring to doing 1 over and then 64, and I can change that to a positive, a half then. So that power now becomes a positive. Then we've just looked at when we have a fraction as the indice, it means we're going to be doing the, in this case, the square root, because the denominator is 2, and then to the power of 1, so that 1 doesn't really matter. So square root of 64, so the answer is 1 over 8. Okay, right, the next one then, this time it says we have 3 to the power of n, and we're going to divide that by 9 to the power of n minus 1, but it wants us to write it as a power. So what I'm going to do first is I am going to write this so it's next to each other. Because it wants to the power of 3, I know that I can change that 9. So I know that 9 can actually be written as 3 squared. Then we're going to use the laws of indices. So I'm going to times n minus 1 by that 2 that's inside. So we're going to have 3 and then 2n minus 2. Now what I'm going to do is the law of indices, when you're dividing, when the base is the same, you just subtract. So I need to just subtract n, and I need to subtract 2n minus 2 from this. So I can write this now as 1 indice. So I'm going to have 3, and then I need to do n minus 2n minus 2. Look how I have put that in a bracket. That's because I need to subtract a negative 2, and it reminds me that 2 negatives make a positive. So my answer here is going to be 3. So n minus 2n is going to be negative n. And then I have to negative 2, which would change to a positive 2. So that is the answer. You can write the negative second. So I'm going to write 3 and then 2 minus n. Makes it a little bit better. So just be careful. I always like to put things in a bracket to remind me that 2 negatives make a positive. 2 negatives make a positive. Right, the next question then, we are looking at a cumulative frequency. So cumulative frequency, notice how, to give you the clue. So this is talking about 80 people and their weekly wages, and it gives it in a table. So here, notice how it always starts from 200, so it's giving me that clue. So basically you have to add up. So eventually you should have the answer 80 here. Okay, because we're taking into account how many people have from 200 all the way to 500. So the first one, there's only 5 people, which is here. So the second one wants to know from 200 all the way to 300. So you're going to add these two together. So that's going to be 15. Then it wants to know from 200 all the way to 350. So you're going to add 15, add the 20. So that's going to be 35. So it's going to be 35 and so on. So the next one, 35 add 20 is 55. And then 200 to 450, you're going to add that 15 on, so it's 70. And then finally add the 10 and 80. So you know you've done that right. It should add up to 80 of how many people you have. Ooh, now what I'm going to do is right, so on the grid opposite, draw the cumulative frequency graph to complete. So that's 2 marks. So I'm going to go over here and I'm going to plot the information that we have just been given. So if it lets me. Right, so the first one was 200 was 5. So that means that my graph, so we always start from 0, which is here. And then we're going to go to the end of each group. So So the first one, the end, so you're going to go to 250 and you're going to plus 5. Because obviously, no one in 200, but we're going to go 250 and 5, which is here. The next one was 300 and to 15. Then we had 350 and 35. Then we had 455. Then we had 450 to 70, which is here. And then the final one, which was 500, it went all the way to 80. And then we're going to join them up. So it's not going to be on the screen slightly, but I'm going to try my best. Like that. It's not a straight line, but that's my cumulative frequency. So that's that one. Right, then it says 60% of the group of people have a weekly wage that is £360 or less. So we have to say, is this correct? And we must show our answer. Okay, so 60 people. Let's work out what is 60% of the 80 people. So I'm going to have 60% of 80. So you can work this out any way you like. You can work out, like, break it down. 10% is 8. And then you could times that by 6 to get what 60% is, which is 48 people. Okay, so if I then go to the graph and actually read off, 360 is going to be here. And if I go along from my graph, it is, because I draw that graph a little bit better. Oh no, oh no, oh no, oh no, oh no. Sorry, my mistake. That was my mistake. 360 is here. So we're going to go up to about here. And then we're going to go along to here. So it's about, on my graph, 38. It's not drawn the best just because it's on the iPad. So then I am left with, what was that? 38. So I'm going to have, okay, well, 38 people out of 80 is 38 people. 80 is going to be, well, it's less than 50%. Is 47.5%. So you can see how 47.5% of people have a wage less than £360. So in this example, he's not correct because he said it is 60%. Right, let's move on to the next question. So for this one, we have liquid A and liquid B are mixed. Liquid A has a density of 70 kilograms meters cubed and it has a mass of 1,400 kilograms. So straight away, I know that I am looking at the triangle, which is mass, density, volume. So it says we're going to mix A and B together to make C. So it wants to know what is the density of liquid C. So the first thing I'm going to do for the first one is I'm going to work out what the volume is. So liquid A, I know the mass and I know the density. So that means here I'm going to divide them. So mass over density gets me volume. So for this question, we're going to have 1,440, that's the mass, divided by 70, cross a 0 off each, and I'm going to have an answer of 20 meters cubed. So for this first one, I know that the volume is 20 meters cubed. Right, for B, they've told me the density and the volume, So density and volume, I'm going to use that to work out the mass. So density times by volume. So for this question, mass is going to equal, what is it? So we have these two numbers. So density is 280, and I'm going to multiply that by 30. So the answer is 8,400 kilograms. So mass is 8,400 kilograms. Okay, now I'm going to work out the density of C. So if I'm mixing these two things together and I'm working out what the density is, I need to add the masses together and the volumes together, and that should give me the answer. So I need to do mass divided by volume. So in this case, my mass for A was 1,400. My mass for B, I have just worked out, is 8,400. So I'm going to add them together. Then the volume, so the volume for A was 20 and the volume for B was 30. So that should give me the density for C because I'm mixing them two things together. So I need to do 9,800 and I need to divide that by 50. So we can cross a 0 off. And then I need to work out what is 980 divided by 5. Well, we do know 1,960 over 10 if you times both of them by 2. So your answer is 196. Right, next question, we have a probability question. So it says Sally plays 2 games against Martin, so she can win, draw or loss. So it might be easier for this one to draw a tree diagram. And we have win, draw, loss. And because the question says she's playing 2 games, there's going to be 2 parts to this. Okay? So win, draw, loss, win, draw, loss, win, draw, loss. So each game, the probability that Sally wins is 0.3. The probability that she draws is 0.1. So remember, probability is out of 1. So that means these two added together would be 0.4. So the probability that she loses is 0.6. Then I'm going to carry on reading to make sure it's independent and not conditional. So work out the probability that she wins exactly one of the 2 games. Okay, so it's each one's independent. So that means I can fill in the rest with exactly the same probability. 0.6. Okay, right, so the question wants to know, work out the probability that she wins exactly one of the 2 games. So exactly one. So she doesn't win 2. She wins exactly 1. So that means she can win the first one and she can either draw or lose. If she draws the second one, that means she has to win the first one. She has to win the second one. If she loses the first one, then she would have to win the second one. So there's 4 possible outcomes here. So when we do probability, you just times them. So the first one is 0.3 times 0.1, 0.3 times 0.6. Then we have 0.1 times 0.3 and 0.6 times 0.3. So if we work them out, we've got 0.03, 0.18, 0.03, and we've got 0.18. So now, because I want to work out the total, I need to add them together. I haven't really got the space, so I'll do it at the top. So we've got 0.03 plus 0.18 plus 0.03 plus 0.18, and that gives us a total of 0.42. So that is the probability she wins exactly 1 game. Okay, right, the next one then, question 15, we have an equation of a line which is y equals 3x minus 4. The straight line of the second one is perpendicular and passes a specific point. Find the equation of line 2. Well, from the first line, I can see that the gradient is 3. So I know if something is perpendicular, we know that if you times the first gradient with the second gradient, it has to equal -1. So it's the negative reciprocal. So for line 2, I know that my gradient is going to be -1/3. Then it wanted to pass this specific point. So I know the equation, y equals mx plus c. So I know what m is, it's -1/3. I know x is 9, which is here, and y is 5. So I'm going to substitute all that information in, and that should tell me what c is. C is the y-intercept. If I graph it, where it crosses the y-axis. So 5 equals -1/3 times by 9 plus c. So 5 equals -9 times 1 divided by 3. It's going to be -3 plus c. Add 3 to both sides, and I'm going to get 8 equals c. So now that I know what c is, I can write that in with the gradient, which is -1/3x, and then I'm going to add 8. Right, let's go to the next question then. Okay, so it says, on Monday, Shirley catches 80 bees. She puts a mark on them and then she returns them back out. On Tuesday, she catches 120 of the bees. She finds 20 of them still have a mark on. We need to work out the estimate for the total number of bees in the hive. Okay, so on Monday, she tags 90 of the bees out of the total population, and we don't know how many bees are there altogether. But on the Tuesday, she catches 120. So that was the whole amount she catches, and 20 of them have a tag on. So we can use this proportion to say, okay, well, if these have to be the same in terms of if it was accurate, that should get me what x is. So there's a couple of ways we can do this. So first, I'm going to cross that 0 off, and I'm going to simplify that to a sixth. So 90/x is 1/6. Right, you can bring the x over, etc., but I really like to cross these over. So 1 times x is just x, and then 90 times by 6 is 540. So we can estimate that there's 540, based on this experiment, that there's 540 bees in the hive. Right, we're going to say she assumes none of the marks have rubbed off between Monday to Tuesday. If it's wrong, how would this affect the answer? Well, if some of the marks actually came off, that means that she should have, some of the bees that are in the Tuesday collection, they should have tags on. So that means the number that she gets would be too high. It's an overestimate for this question. She would overestimate how many bees would be there.